All right, in this video, I'm going to try to help you understand formally what the term continuity means. And informally, I think it's a fairly intuitive term. If something is continuous, it has no breaks. In other words, you could draw a function without lifting your pencil. So let's go ahead and look at the formal definition. And it says that a function is continuous, so f of x is continuous at a point A, at A, if these three things hold true. So if and only if these three things hold true. If f of A is defined, if the limit as x approaches A of f of x exists, and finally, if those two things are equal to one another. So if f of A is equal to the limit as x approaches A of f of A. So I'm going to draw a few pictures and look at a couple of scenarios. So here's a point A, and let's say the graph looks something like this. All right, here's another scenario. Here's A, and let's say the graph looks like this. All right. And then a third scenario. Here's A. And let's say I have a vertical asymptote here, and it looks something like this. Okay, so it's going up to infinity on both sides. And then the final situation looks something like this. Here's A, and let's say you have a situation that looks like this. It's actually filled in, or it looks completely smooth at that point. All right. Let's say this is like 2. So this is 2, 3. Okay, so let's look at these 4 scenarios. So in this first scenario, we see that f of A is defined, okay? So I'm looking at these 3 criteria for each of these graphs. So in this first one, f of A is defined, and f of A, the actual value at A is, it looks about like 2. So f of A is equal to 2 in this case. Now we're looking at the limit as x approaches A of f of x. And remember, if we're looking at the limit as x approaches A, we have to consider what the graph is approaching from both sides. And so from the left side, this graph is approaching a y value of 3, isn't it? But from the right side, the graph is approaching a y value of 2. So that means that the limit as x approaches A of f of x does not exist, right? Because approaching from the left side and the right side, they're not the same. So since the limit does not exist, the second criteria is not met, and therefore we can say that f of x is not continuous, or we can say it's discontinuous at A. Let's look at the second situation. In the second situation, we see that f of A is equal to, well, the actual value at A is up here, isn't it? This point is filled in. So at A, the y value is going to be 4, right? Now let's look at the limit as x approaches A of f of x. And from the left side, it's approaching a y value of 2, isn't it? See, that's a y value of 2. And from the right side, it happens to be approaching the same y value of 2. So since the limit from the left side and the right side is equal, we can say that the limit is 2. Now the third so it meets the first criteria and the second criteria. Now the third criteria is that those two values must be equal to one another. So f of A must equal the limit as x approaches A. And since 4 is not equal to 2, the third criteria is not met, and therefore it too is discontinuous at A. All right, let's look at the third scenario. In this case, we have that f of a is undefined, right? The actual value at a is undefined. So since it is not defined, we know that the first criteria is not met. And so even though the limit as x approaches a, let's go ahead and look at the second criteria, the limit as x approaches a of f of x happens to be positive infinity, because from the left side and the right side, it's both going to positive infinity. Since f of a is undefined, we know that this is not continuous at a. All right, and let's look at the fourth scenario. If we look at the fourth scenario, we see that f of a is equal to, well, the actual value, since there's not a hole there, the actual value of the function at a is going to be 2. And then when we take the limit as x approaches a of f of x, from the left side it's approaching 2, and from the right side it's approaching 2. And so the limit is also 2. And since those two are equal to one another, since f of a is equal to the limit as x approaches a of f of x, we can say that this satisfies all three criteria and is therefore continuous. So you can see intuitively this looks continuous. This fourth example looks continuous, but it also makes sense with the mathematical definition that it's continuous.